lesson, we'll focus on all of the different ways that we can rationalize the denominator, which means to get the radical out of the denominator because it's not really mathematically polite to leave it there. So in this case, we have a -4 over the square root of 14. Some people will get tempted to reduce the 4 and the 14 and make that be -2 over root 7, but you can't do that because one number is outside the radical and one number is inside the radical, and you can only reduce if they're both outside or both inside. So I have to rationalize this. I will do that by multiplying by root 14. So on the top, I just have -4 root 14, and on the bottom, root 14 times root 14, basically what that means is it's root 14 squared, and the square root will undo each other, and you will just have 14. And then now you can take this -4 over 14 and reduce it to make that be -2 over 7. And of course, you still have the root 14 here. Okay, so you can reduce anything outside the radical and anything inside the radical, but you can't kind of cross planes there. Okay, we are actually going to skip numbers 2 and 3 because numbers 2 and 3 because really it'll be overkill. So we're going to jump to number 4 here. Here, what I want you to notice is that you have 2 radicals in the denominator, and they are separated down here by a subtraction sign. And so this you need to think of as one big giant quantity, and you need to rationalize that whole entire quantity. And whenever you have radicals in the denominator where there's 2 terms, and there's 2 terms here, there's one term and there's the other term, you have a binomial, you rationalize that by using what's called the conjugate. And the conjugate, I will just spell that for you, conjugate, like that. The conjugate is basically multiplying it by itself, and the only change you're going to make when you do the conjugate would be to switch the middle sign. You never switch the sign in front. Don't ever touch that. You only switch this middle sign right here. So the conjugate to -11 root 10 minus root 2 would be -11 root 10 plus root 2. And if you do that to the bottom, you must do that to the top also. So now what I get to do on the top is I get to distribute. So 4 times -11 root 10 would be -44 root 10. And 4 times root 2 would be 4 root 2. On the bottom, you get to sort of distribute this. So here we go. -11 times -11 is 121. And then root 10 times root 10 is root 100, and we'll simplify that in a minute here, okay? And then we have this, -11 root 10 times root 2 would be -11 root 20, and we'll worry about simplifying it later. And then -11 root 10 times -root 2 would be positive, a negative times a negative would be positive 11 root 20. And at the end, -root 2 times positive root 2, a negative times a positive is a negative, and then we have root 4. Okay? Luckily, we don't have as much simplifying to do as we think we would at the beginning. The -11 root 20 and the positive 11 root 20 cancel each other out, so that's good. So root 100, by the way, is 10. So I have 121 times 10. And back here, root 4 is 2, so I have -2. So I have basically on the bottom 121 times 10, which is 1,210. And then I have this -2. So that whole entire bottom ends up being 1,208. Okay, so that's the bottom simplified. So now if you look at where I'm at and make this just a little bit prettier, I have on the top -44 root 10 plus 4 root 2. And in the denominator, all of that mess turned into 1,208. And now what you want to do is you want to make sure that you can simplify if it's possible. So what I know is that -44 and 4 and 1,208 are all divisible by 4. So I'm going to divide each of those by 4. I'm not going to touch what's in the radicals. I don't need to worry about that, but I'm going to divide all the rest of those by 4. So negative 44 divided by 4 would be negative 11 root 10. And then 4 divided by 4 is 1. Root 2, I don't need that 1 there. In fact, I probably shouldn't have that there, but just so you can see that. And then on the bottom, 1,208 divided by 4 would be 302. And that is as simple as this answer can get. Some people, just so you know, let's say that this was a 5. These two numbers here would still be divisible by 4, but then this 5 that's right here wouldn't. And then you can't reduce anything, just so you know. All 3 of these coefficients, or all 3 of these numbers here, would have to be divisible by something in order to reduce it, okay? Now, this next one has variables in it. If I look inside the radical, I could, if I wanted to, write this as one giant radical with 3 over x like that. It doesn't really help me because nothing can be reduced, so I'm really not going to worry about that, and I need to get this radical out of the denominator, so I will just multiply it by itself, and on the top I will have negative 3 root x, and on the bottom I will have the square root of x squared, which these two just undo each other, and you just get x, no longer in the radical anymore. You could also think about it as if it was written like this. Here's your numerator and here's your denominator if you want to write it as a fraction instead, which of course just becomes x to the first power. So whichever way you want to think about it, this is what you should get. All right, here again I've got a radical in the denominator and I need to rationalize that. I do not need to rationalize the 7, so I'm going to make this be as simple as I can, and I will multiply this by x to the 5th. I'm not going to worry about the 7 right now. I'm just going to get rid of the radical, which is my main concern here. On the top, out in front of the radical, I have a negative 10. And inside the radical, I will have 10 times x to the 5th. In the bottom then, when I take the square root of x to the 5th times square root of x to the 5th, basically that just gets rid of the radical and it leaves me what's inside. So on the bottom, I will have this 7 that's right here, and then x to the 5th, okay? So I would be done if I couldn't break anything inside that radical down. However, I can break that x to the 5th down. Again, there's this little imaginary 2 right here, so if you're thinking about doing the square root of x to the 5th, that's really x to the 5 over 2, which is really x to the 2 and 1/2. And then here's your outside exponent, here's your inside exponent. So that x can come on the outside and I can reduce all of that. So this really becomes negative 10 x squared times the square root of 10x all over 7x to the 5th. And then I can do one more thing, which is to reduce these guys. They're both outside the radical, so I can reduce that, which would leave me with negative 10 square root of 10x over 7x to the 3rd. Okay? All right, next one. Here again, I can think about this as one giant radical, and I can reduce this 5 and this 15 to make that a 1 and a 3. So now what I really have is the square root of 3 over the square root of q. Still can't leave that radical in the denominator, so I do need to rationalize it, but now I'm dealing with smaller numbers, and I can multiply by root q. And then on the top, I will have the square root of 3q. And on the bottom, I will have the square root of q squared, and the square root of q squared would just be q. Okay? When you multiply by itself, you're left with what's inside. All right, last one. This is a little bit more complicated, but not too terribly bad. Again, you're going to reduce whatever you can reduce from the get-go. So if you've got things that are both underneath radicals, it would be easiest to reduce them. So I am going to think about taking this 108 and 3 and reducing it. And so actually, I'm going to write it like this so that you can not be confused. we can think about this as one giant radical right now. Okay, so we're going to reduce what we can inside that radical first. So the 108 divided by 3 reduces to be 36. So I will have the square root of 36. The x to the 7th over x to the 5th leaves me with an x squared on the top. And then here, y over y squared leaves me with just 1y on the bottom. So now, if you think about splitting that up, back up into a numerator and a denominator, here's where I'm at. The numerator can simplify. The square root of 36 is 6. The square root of x squared is x. So I don't even have a radical anymore. And in the bottom, I have root y, which I can't leave that root y in the bottom. So I rationalize it by multiplying by the square root of y. And then on the top, I will have 6x root y. And on the bottom, root y times root y is just y. And there is my grand final answer. All right, here we have another binomial that is being multiplied together. So I have two terms, one term, two terms, separated by an addition sign like that. The way to rationalize that, just a reminder, would be to use again what's called conjugates. A conjugate means you think about this as one quantity and you multiply it by itself, except for you change this sign that's in the middle. That's the only thing that gets changed. So I will leave this as a square root of x and 2 root y, and I will change that middle sign to a negative instead. And if you do that to the bottom, you must do that to the top too, so that it's like you're multiplying by the same quantity over the same quantity, which is really like multiplying by 1, and it doesn't change the value of the problem. Okay, so on the top, I will distribute. 3 times root x is 3 root x, and then 3 times negative 2 root y is negative 2 root y. On the bottom, root x times root x is x, and root x times negative 2 root y would be negative 2 root xy. And then positive 2 root y times x would be positive 2 root xy. And then here on the outside, 2 times negative 2 would be negative 4, and then root y times root y would be y. Fortunately, these two things cancel each other out, and I would have 3 root x minus 2 root y all over x minus 4y. And that is what I can do. All right, and I think we will skip this one. I will just tell you that when you do this, you would multiply by root x plus root 7, and then go ahead and distribute this through the top, and obviously FOIL out the bottom, and that should do it.